For any assignment-related queries, call us at +1 678 648 4277. You can mail us at support@mathhomeworksolver.com or reach us at https://www.mathhomeworksolver.com. Late homework policy. Late work will be accepted only with a medical note or for another institute-approved reason. Cooperation policy. You are encouraged to work with others, but the final write-up must be entirely your own and based on your own understanding. You may not copy another student's solutions. And you should not refer to notes from a study group while writing up your solutions. If you need to refer to notes from a study group, it isn't really your own understanding. Part 1. These problems are mostly from the textbook and reinforce the basic techniques. Occasionally, the solution to a problem will be in the back of the textbook. In that case, you should work the problem first and only use the solution to check your answer. Part 2. These problems are not taken from the textbook. They are more difficult and are worth more points. When you are asked to show some fact, you are not expected to write problem. Problem. Worth more points. When you are asked to show some fact, you are not expected to write a rigorous solution in the mathematician's sense, nor a textbook solution. However, you should write a clear argument, using English words and complete sentences that would convince a typical calculus student. Run your argument by a classmate. This is a good way to see if your argument is reasonable. Also, for the grader's sake, try to keep your answers as short as possible, but don't leave out important steps. Part 1. A. 4 points, p. 181, Section 5.4, Problem 12. B. 4 points, p. 283, Section 8.5, Problem 16. C. 4 points, p. 374, Section 10.9, Problem 4. D. 4 points, p. 225, Section 7.2, Problem 25. E. 4 points, p. 229, Section 7.3, Problem 7. mathhomeworksolver.com. Part 2 Problem 1 For each positive integer n, consider the collection of curves y equals cxn, where c varies over all real numbers. A. For y equals cxn, find the derivative dy/dx. Then use the expression y equals cxn to eliminate the constant c from dy/dx. Write your answer in the form dy dx. For some function f that does not involve c, b, a differentiable function y equals g, x, has the property that for every point a, b, on the graph, the tangent line to y equals g, x at a, b, is orthogonal to the equals f, x, y. b, on the graph, the tangent line to y equals g, x at a, b, is orthogonal to the tangent line to y equals cxn at a, b. Here c is chosen to be BC equals and so that a, b, is on the graph of y equals cxn. Use the hypothesis to write a differential equation g, x, satisfies. Hint. The differential equation is separable. C. Solve the separable differential equation to find all curves y equals g, x, satisfying the hypothesis. Express the curve implicitly in the form mathhomeworksolver.com. G, x, y equals e, where g, x, y is a polynomial and e is a positive real number. Problem 2. Solve problem 11 on p. 229 of the textbook. The answer is in the back of the book, and even in the statement of the problem. You are responsible for showing the work and explaining the steps leading to the answer. Problem 3. A cone over a plane region R is the solid obtained by joining every point in R to a fixed point P not in the plane. If the height of P above the plane is h, and if the area of the region R is A, the volume of the cone is 3. Prove this fact by computing the volume using the washer method. You may use the fact that if a plane region is scaled by a factor c, the area scales by the factor c too. V equals A. 1. Fact that if a plane region is scaled by a factor c, the area scales by the factor c too. MathHomeworkSolver.com. MathHomeworkSolver.com. Solutions. Solution 2, A. We rewrite the equation and integrate both sides to obtain where c is a constant, which is going to be determined by the initial condition y equals 3 when x equals 2. Thus we have 32 plus 2.3 is equal to 23 plus 5.2 plus c, which yields c equals 26. In order to obtain an expression for y in form, we complete the left-hand side to a complete square. Note that we chose the plus sign for the square root to be consistent with the given initial condition. Solution to AB, we are given the equation LDI equals ERI, which is separated as in order to integrate this expression, we make the substitution U equals ERI, do equals RDI, where 1I equals EU, which transforms the integral in question to, which integrates to MathHomeworkSolver.com. So for a general initial current I0 equals I0, the current is given by in particular, the initial condition I0 equals 0 gives the solution. The graph of this current, as well as for several other choices of I0, are on the course webpage. Solution to SE, conveniently, n equals 4 corresponds to evaluating the function at the points 1, 2, 3, 4, 5. Note that BA equals 5 1 is equal to 4, and 4 equals n equals 2 m equals 2. The Simpson formula then given solution to D, we first need to calculate the tangent line of y equals x3 at x equals 1. As the slope of this line is given by y, 1 equals 3x, x equals 1 equals 3, it is given by MathHomeworkSolver.com. A graph of the region is included on the web page. In order to calculate the area between this tangent line and the graph of y equals f(x), we need to find the other point where the two intersect. Let's denote this point by u3. Remember that this point is on y equals x3. Then, by plugging into 1, we obtain u3 equals 3u2. This can be rewritten as, which, at first sight, not easy to solve. However, since the tangent line touches the curve at u equals 1, we know one solution is u equals 1. In fact, u equals 1 is a double root, because the tangent line is tangent to the curve at that point. Therefore, we should be able to rewrite 2 in the form, where a is the other root. By multiplying out, or a simple inspection, we easily see that a equals 2. Therefore, the sought integral has the limits 2 and 1. Hence, solution to E, from the figure on the course webpage, each section has volume dv equals adx equals h2 dx, 2, and we have the constraint x2 plus h2 equals a. Therefore, the total volume is given by MathHomeworkSolver.com. Part 2 Problem 1. For each positive integer n, consider the collection of curves where c varies over all real numbers. A. For y equals cxn, find the derivative dy/dx. Then use the expression y equals cxn to eliminate the constant c from dy/dx. Write your answer in the form for some function f that does not involve c. Solution to A. By differentiating y equals solution to A. By differentiating y equals cxn, we obtain dy equals cnxn1. One way to get rid of c is dx to write, where we used both our equations to obtain expressions for c. Thus, we have obtained, which is the required differential equation. Note that this equation does not involve c, and it is satisfied by y equals cxn for any arbitrary c, b, 5 points, a differentiable function y equals g, x,